Right, hello everybody, as usual, and welcome to the Livy Lab. Yes, we're downstairs, and for the first time we're utilising the new geek table. Don't worry, this table is being used. It's just that at the moment, it's a brilliant facility for doing these kind of operations. Now I'm going to have to apologise for the background noise, because the buggers outside, oh, right, just going to go get the multimeter while talking. The buggers outside have decided, back in position, they've decided to clean the drains and stuff today. So, bit of background noise, keep you entertained. Music, just think of it as music. Well, it'll work. So, yes, utilising the geek table today. I have all the essentials. Key, soldering iron, multimeter, tape box and Einstein sitting over there. Yeah, it's a bit of a mess at the moment, but hey, what are you gonna do? Right, today's task. We're having problems with this keyboard, as you may know. So I'm just wiring in the multimeter while I'm talking. When we tried it on the Einstein, well, when we put the Einstein back together, it was producing, well, I won't accuse it, because it may not ultimately be the cause. But we were getting random characters coming up, keys that appeared to be getting stuck. Ugh, bloody cleaner. Ugh. Keys that were getting stuck, and keys that weren't working whatsoever. So, first thing we got to do is test all this at the keyboard end. Bloody thing. Now, on the back of the keyboard, we have the traces. These are the electrical connections. These are the electrical connections between the keys and the computer itself. The keys are basically behind here, and for example, if I just zoom in on one of these, here you can see two contacts with nothing. Oh, excuse me. Let's get this sorted. There we go. Right. That's the one, isn't it? Yes. Here you can see two bits of solder with nothing in between. Now if I get the multimeter and put it in the continuity mode, what this does is test for electrical connections. So if I get the probes in front of you there and I touch the probes together, circuit is created and the multimeter beeps. Now, I've got to find the right key now. You silly bugger. Okay, let's zoom back out. So if I touch one of these connections here, put one either side, then you'll hear there's nothing. If I find the right key, press the key on the back, you can see it makes an electrical connection. That allows me to go through the whole thing and test every key. If the key is stuck down, let's see if I can find an example. 0 is stuck down. There you go. Even without pressing the key on the other side, we'll get a connection. If the key is broken, not making a connection, when we press it, there'll be no signal. Now, this is also, we need to test all these traces. These can get damaged, and this one's, they're dirty. Look a bit, yes. But they look solid, but dirty. So, this allows me to test all the traces, and it's a laborious process, but I'm a geek and I can take it. But, what we do, start at one end, touch the trace, and we don't have to trace every individual one to the pin, we can just do this, run down, there we go, and you can see, makes a connection to that one. So that's one working. We can now do another one. And there you go. Using this system, we can test every trace. There we go. So we can work our way across the board testing every one. for connection. So that allows us to map any bad traces, and using the this technique we can map any faults in the keys themselves, which is what I'm going to do now. I did it last night, but I'm going to do a more thorough job right now, and I'll be back when I've done that. Nice sweetie. Right, official figures are in. We have 13 keys that have no connection and 3 that are stuck. So these are going to come out the board. But what I'm going to do first, no connection keys. We've got 13 of them. So what I'm going to do is find one of the keys that's easy to get at. This one, F0. 2 connections there. I'm going to put a pen there so I can remember. And what I'm going to do is try the most simple thing first of all, and just reflow them by heating the solder up, letting it dry. There we go. And that's just called reflowing. Sometimes when solder gets old it loses its conductivity, and simple reflow can work. I am not expecting this to work, but it's always worth a shot, isn't it? Okay, where are we? There we are. Let's put the multimeter back on. Test the probes. Press them against there and press them, key them. No, I didn't think that would work, but it was worth a shot, and that's one thing you can do with dry joints. I will be doing this on all of these keyboard connectors here. So what I've got to do is take these keys out and find out what's wrong. So these have individually got to be removed, but they're soldered through the board with connectors inside, so I'm not sure how or if I can get at them. As you can see, they have little cases inside, so I'm going to try and desolder and see if I can get inside. I'll be right back. Right, we are having trouble getting these off. Desolder, but they seem to be connected inside, so I thought I'd take this opportunity to introduce you to my little friends here. These are my new glasses, and they go up to 20 times magnification, although at the moment I've got them set for 20 and 10 on this side. They have little LEDs as well, so this allows you to get right inside, and that's exactly what I'm going to do right now. I'm going to use these to have a look under the keyboard. So thought I'd tell you that. Well, there's good news and there's bad news. We found how it's connected. Unfortunately, we've got to desolder this entire section to get at that. Oh well. Best I crack on then, aren't I? Be right back. Well, eventually. Right, about an hour and a half later, and we've desoldered all of these, and we've got it to separate. Might be fun getting that back together, but there we go. For now, we've got one of these little mechanisms out, and here they are. Now, to get these apart, I need the help of my little screwdriver here. I've already had this apart, so hopefully it shouldn't be too bad to do it again. Right. Now we just push these apart, and hopefully there's a little bit of convincing. Come on. Come on, you know you want to, you did it earlier. There we go. What we have, let's readjust the camera here. Right, what we have is, oh, here we go. Fully out, just. Right, what we have is the key sits on there. So yeah, key sits on there. Just push it down, spring loaded, and then that goes down into this bottom pit and pushes the metal contacts together. So simple when you know how. You have to take a picture of this for the internet. And yes, we'll go in. This is a good one. We'll go in and see what is wrong with the ones that are not good. Okay, be right back. Okay, and here's the one inside the A key, which was stuck down, and you can see the spring has moved out of position, so that one's an easy fix. Let's go and find one that has... I'll fix the rest of these and then find one that's failing to get contact and see what's happening there. Right, causes of sticky keys on the Einstein. I've found the causes, and this has been a big question on the internet, if I could get in here to see what actually causes this. I have to excuse, I've been swapping keys over to experiment. What I've found, there are two causes. Obviously one's where the springs come loose inside, that's easy to fix. The other one, where they get, like this one, a bit stiffer than usual, and they slow down. The A's suffering from it as well. It's slow. That's normal speed. That's a that's normal speed. That's a slow one, and they can get stuck open and cause problems. Now, what I found is on the bottom, when you take these out, I'll take this one out. When you take them out, they run a bit faster. Now, I found that what it is, some are susceptible to this, some aren't. But with that one, if you press on the side, it gets slower and slower. So obviously when it's in the cage here, that causes that sideways pressure causes it to slow right down. To relieve this, what you can do is apply pressure to the other side. There you go, and it speeds right back up. So what I'm doing in here is just going to wedge little bits of wire in between, in the hole in those sides. It won't be seen once the keyboard's put together, but it does the trick. So that's the reason that I found that they slow down. So there we go, and I've put pressure on the side. Speeds back up. So that's the reason for that, I have found. So I'm going to repair the keys and try and put this thing back together. Obviously still got no space bar. Well, I've got a space bar, but it's a wee bit bent. Yes. Not good. But there we go. Right, I shall continue. Right, it is now the next day, and I've already been doing a bit of work. I've got some of these keys working, but I wanted to show you how to restore one of these broken keys and things I've found. Now I've covered the stuck ones. I've got to take these out and put the wires in them, but I've been concentrating on the ones that got no connection. So, done a couple. Well, I've done 3. Aren't I good? Next is T. Now, let's get T out. Extract Mr. T. Now the problem is, what I've found, if I just put that there, my probe's on, I can see that this guy is dead. There we go, no response. Now, I found, in the case of this particular machine, that this is due to erosion on the contact points. Well, first of all, we've got to get at the contact points, which on this is quite an intricate thing. And the only way to get at them is to do some damage. So be careful when opening this, because there is a spring and it will go flying if you're not careful. So put that carefully to one side, put that there because we don't need that. Inside of it, you will find this. This is a little lever which goes down. When the key goes down, this travels down, pushes a little, excuse me, that has a little knob on it which pushes two plates together, the anode and the cathode plate. Now, these are securely first fixed in. The corrosion is appearing on one of the plates. These are securely fixed into the case, so you've got to be a bit nasty to get it out. So I'll just push it hard against this, and hopefully been a pain, but they do eventually come. You've got to push these out of the case, which is no easy feat. There we go. Yes, it sounds violent. It is violent, but it's the only way to extract them. Now, you usually get bits of solder stuck in the last few seconds. Are the worst. What I'm going to do first, before I do this, is to remove this little metal thing so I don't damage it. Just a clip, and it will go flying if you're not careful. I've had two fly across the room. Now try and very gently, but brutishly. There we go. Final extraction. So we can see the mechanism itself. Got a back plate, and in there is a little plastic ring separating the anode and the cathode, which is the front here. So when you press on that key, that metal thing comes down, hits this bit of plastic, which pushes them together. Now, we are going to have to brake to get at it. We have to rotate this plate out the way. So we are going to have to break one of those to get at it. But the good news is, those are not important when it's put back together, because it will hold itself in position. So if I just there we go, quickly break that. Just one side will do. Rotate this out of the way, and there you go. You can see the corrosion on the plate there. So all I'm going to do is, let me check actually. Let's do a continuity check. Yeah. Oh, and on this one as well, you can see the corrosion affecting that side. There it is. So all I'm going to do is get some, swab some pipette alcohol and give it a quick clean. Now, the staining on the metal part here will not come off, but on this part here it does come off. So give it a good wet and dry. Make sure there's no fibrous deposits left behind, and we shall start reassembly. Somebody's car alarm's going off, so we just put them there, straighten these as best we can. Now this is the fun part, because you've got to get back through these holes, and alignment with it being twisted out can be fun. There we go. But if it argues, you can just push your screwdriver through and just widen those holes slightly. Don't worry, this key is quite well designed. It will hold itself together once this is all pushed back together. So, put our little clip back on. Insert the spring into there. and very gently, where are we? That way round. Place that part into that part, push up, clip home, check movement, and then with our multimeter on continuity, one on one anode, on the cathode, push down. Come here. Oh, been a pain. As you can now see, there's a key, flashes up and down. We've got continuity. So that key is now working once more. And that's how I restore them. So, I'll be right back. Right, just a quickie, just to show you that you can test the mechanism before it goes in. Put it on a non-conductive surface like this, one probe on each leg, and just press down. There we go. You can test it works before putting it back in. Excellent. Right. Next, just another quick tip for you to make life easier. This red stuff bonds these contacts to the case, so you might want to, if you just mess around with them, this red stuff eventually comes away, making life much easier to get in there. Right, this project is now in its 14th hour of work, most of which has gone to this keyboard. Right, we have rebuilt all the keys. That has taken about 12 hours. You can see the ones I've done because they're the ones with the red stuff missing, which is holding the pins in. Not necessary once the keys are assembled, because they hold themselves together. Now, we did have the ones that respond slowly, that had the problem with the side pressure. You can relieve that by putting pressure on the front and back, but I can't find a way to do that in the keyboard itself once it's assembled, so they've been moved up to the high function keys, where they won't be used as much. Also, a couple of them got these snapped off in the process, accidentally, so I've moved them up there as well. Hopefully, when we solder this PCB back on, we can try and get a contact to them, but if not, well, they're up there all the way. The other thing, TCP, yes, this keyboard, all the time I've been operating on it, it's covered, stinking of TCP, and I did find the reason. This somebody spilt it on it, and this back plate was covered. This is much better than it was. This has been scrubbed, and all these were corroded, and they've all been cleaned off, checked, everything's fine now. So, what I've got to do now is solder all of that back on to that. I'll be back. May take a while. Okay, it's all soldered back together. I've done some random checks, and they all seem to be okay, apart from the two that got the tabs snapped off. They don't work at the moment. But I'm going to push on. What I can do is put a wire in there eventually. But I'll come back to that some other time. I want to push on and get this thing back together. So next, it's time to loosely wire it up to the Einstein and see what responses we get. If it's an improvement on last time, we shall see. Okay, here's the Einstein with its keyboard loosely plugged in test mode. And here's the TV. So, let's switch her on and see what happens. Well, I know what happens because I've been doing some testing. Einstein. There we go. We are booted. Let's try some keys. First of all, try control break, because that's the to boot. And appears to be trying to boot. Now, this machine has a lovely picture, even on the big TV here. So, yeah, that's trying to read. There we go. Tried to read the disc. So, I'll start working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, equals up, down, and the brake obviously works. And the escape key which does seem to slow the cursor down there, so that's working. Okay, QWERTYUIOP, line, back arrow, right, down, enter, yep. Control, oh yeah, that works because it booted. Alpha lock, yep, alpha lock, ASDF, oops, F, GHJKL, semicolon, that one, right key, enter. That's just throwing back a memory response. Right, Z, X, C, V, B, N, M, F, comma, full stop, arrow, shift key, left shift, yep, right shift, yep, instant delete, insert delete, sorry, and the graph key, which I don't know whether that's working because I have no use for it at the moment. Now the F ones, I know that 2 of them are out because their tabs are broken. I will be doing a repair of that in the future, but oops, yeah, I will have to reboot it because it's gone off the screen. That's the thing about these. There we go. Right, Einstein. Now, with the F keys you can't get a response obviously, but you can see it interrupt the cycle of the cursor. There you go. That one works. That works. You see that one doesn't because that's got no tabs on it. That one doesn't. Oops. And that one does. So, there we go. Success. What's left now is to put it together. Also, I've just spotted the LED on this left-hand drive doesn't appear to be working. When I first tried the computer, it sort of flashed on and flashed off, so that's something else that will need to be done. And the spacebar works. Trust me on that one, it's just going across the screen. Looks ugly because it melted slightly in the oven. Nice screw up, but yeah, it's working. I'll now put it back together and you can have a final look.
You need to quit being dirty. You're a dirty boy.